Hi everyone, here is your homework help video for Chapter 2, Lesson 5. All right, starting us out here, we have a little bit of review and refresh from previous lessons. We are multiplying decimals, so we're going to go 1.31 times 0.5. 5 times 1 is 5, 5 times 3 is 15. 5 times 1 is 5, and another is 6. And we have 3 digits after a decimal point. And then we had a negative times a positive, which is a negative. So that would put us at negative 0.655. For number 2, the first thing I notice is that I have a mixed number, so I'm going to turn that to improper. 1 times 4 is 4, and another is 5/4. Then I'm going to multiply times 9/10. So I could simplify first, or I could just multiply across the top. And I get 9 times 5 is 45 over 40. And 40 goes into 45 once, with 5 left over. And then I need to simplify here. Divide by 5 over 5. And I get 1 1/8. Then I had a positive times a negative, so my answer is negative. So negative 1 1/8. And then the last one, looks like I can just multiply right away. However, because my numbers are bigger, I actually want to show you how you'd simplify this one first. 3 is a common factor of 3 and 12. So let's say 3 goes into 3 once and 3 goes into 12 4 times. That is simplifying before we even multiply, which is going to make our lives much easier because now we have negative 7/4 times negative 1/14. So our numbers that we're multiplying are just going to be quite a bit smaller. We'll have 7 and then 4 times 14, that's going to be 56. And now we can take 7/56 and we can simplify that, divide by 7 over 7. 7 divided by 7 is 1, 56 divided by 7 is 8. So we end up with an 1/8, and a negative times a negative is a positive. So that just stays 1/8. For question number 10, I see that I'm dividing fractions. So instead of dividing the fractions, I'm going to multiply by the reciprocal. So I'm going to take negative 7/10 and multiply by 5/2. 7 times 5 is 35, and 10 times 2 is 20. 20 goes into 35 once, so 1 15/20, and then I'd simplify, dividing by 5 over 5, and I'd get 1 3/4. And then a negative divided by a positive is a negative, so my quotient is negative 1 3/4. For number 12, I'm doing long division. Negative 3.45 divided by negative 15. I'll annex in some zeros there just in case I need them. And now 15 doesn't go into 3, but 15 goes into 34 twice. 2 times 15 is 30. And 15 goes into 45 3 times. 3 times 15 is 45. So I didn't need those extra zeros. That's okay. Now I'll look back and see that I had a negative divided by a negative, which is a positive. So I get positive 0.23. For number 14, I will once again multiply by the reciprocal. And I can multiply 1 times 8 is 8. 4 times 3 is 12. And then 8/12 I can divide by 4 over 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So simplified here, I get 2/3. And then I look back to the original problem, and I had positive 1/4 divided by negative 3/8. A positive divided by a negative is a negative. So I end up with negative 2/3. Number 16, I have 12.42 divided by 4.8. And I can't divide by a decimal, so I need to move my decimal point one place to the right, which is the same as multiplying by 10. And then I need to do the same thing to my number inside, moving it to the right one place, multiplying by 10. So my new division problem is 124.2 divided by 48. Bring my decimal point up, and now I can start my long division. 48 doesn't go into 1 or 12, but it goes into 124 twice. And 2 times 48 is 96. When I take away here, I'll get 28, and then bring down the 2. And 48 will go into 282 5 times, and 48 times 5 is 240. So when we subtract here, we get 42, and we'll bring down a 0. And then 48 goes into 420 8 times. 48 times 8 is 384. 420 minus 384 is 36. Bring down another 0. 48 goes into 360 7 times. 7 times 48 is 336. Take away and get 24. Bring down one last 0. And 48 goes into 24 5 times. And then 5 times 48 is exactly 240. So let's look back to the original problem now. And we had a positive divided by a negative, which is a negative. So we end up with negative 2.5875 as our quotient. For question number 22, for number 22, we do need to follow some order of operations here. And so essentially we have to do what's on the top first or what's on the bottom first. What I mean by that is there'd actually be like parentheses here. So in order to do the bottom, because there's nothing to do on the top, right? It's already just a fraction. We need to get common denominators. And our common denominator is going to be 6. So to get from 1/3 to a 1/6, we multiplied by 2. So 1 times 2 is 2. So here is our new expression on the bottom. Negative 2/6 minus 1/6. We could chop slash it if we need to. And I think for many of you that's helpful because now you see that you're actually adding negatives, which means you have negative 3/6. So that's going to go on the bottom. Negative 3/6. So our new expression is really 14/9 divided by negative 3/6. Although that's written as a complex fraction, it's really just a division problem. 14/9 divided by negative 3/6. And now from there, we just rewrite it, multiplying by the reciprocal, 14/9 times negative 6/3. You can see here that we have a common factor between the 9 and the 6. You have a 3 in common. So you could say that 3 goes into 6 twice. and 3 goes into 9 3 times. And now you can just multiply. 14 times 2 is 28. 3 times 3 is 9. 9 goes into 28 3 times with 1 left over. So we have 3 and 1/9. And then we had a positive divided by a negative, which is a negative. So our quotient is -3 and 1/9. For question 23, this is very similar where we have to solve the addition on top and the addition on the bottom first, and then we can divide. So on top, we have -12/5 plus 3/10. So we're going to need to rewrite with common denominators, and those common denominators would be 10. 3/10 can stay the same. On the left side, we multiplied by a factor of 2 to get from 5 to 10, so we'd multiply -12 by 2 as well. So that would be 24. So now we have -24 plus 3/10. So that's what we're doing right here. -24 plus 3/10. So we actually have -21/10 on the top. Numerator. Now on the bottom, we can chop, and we end up with 20/14. This is our bottom. So our new complex fraction is -21/10 over 20/14. Let's rewrite it as a division problem. -21/10 divided by 20/14. From here, instead of trying to do division, let's change it to multiply by the reciprocal. -21/10 times 14 over 20. And now we multiply the numerator and denominators. 21 times 14, that's not something I can do in my head. So I'm going to say that, as in most of these problems, you're going to have to do long multiplication. And you get 294 over 200. 200 goes into 294 once, with 94 left over. So 1 and 94 200ths. And now we can simplify, divide by 2 over 2, and we get 1 and 47 100ths. And wowie, this one is big, because we still have to go back and we still have to see that we had a negative times a positive, which is a negative, meaning this is -1 and 47 hundredths. That's a lot of steps. Congratulations if you were able to get that on your own. For number 29, we're going to go back to reviewing mean, and mean just means average, and average is the sum of the numbers. Divided by the number of numbers. So here we have to add all of these decimals. 0.05, well, that's negative, plus 0.09, plus negative 0.04, plus negative 0.08. Everything's addition, so let's add our negatives first because we can use the commutative property. So let's add our negatives. So we have negative 0.05, 0.04, and 0.08. So that's 9, and so that's 17. And all of those were negatives. So we have negative 0.17 plus 0.09. Okay, so when we add those up, negative 0.17 plus 0.09, that's going to put us at negative 0.08. And we divide by the number of numbers, which is 4. 0.08 divided by 4. 4 doesn't go into 0. 4 goes into 8 twice. So that would be negative 0.02 inches. That is our average, or our mean. Next, it says the mean change for Monday through Friday, which means they're throwing an extra day in here on us. The mean is negative 0.01. So we already know that the average is negative 0.01. The number of numbers now becomes 5 because we have 1, 2, 3, 4, 5 days. We know that the sum of the 4 numbers that we had adds up to 0.08, and that's actually negative 0.08. And then we're going to add the unknown, which is the value for Friday. So let's use the variable f. So we have negative 0.01. That's our average for all 5 days. The sum of the numbers is negative 0.08 plus Friday, which we don't know, and we're going to divide by 5, which is our number of numbers. So let's take this now and put it on a separate page so we can solve for f and have a little bit more space. All right, so now that we have this equation set up, we will draw our line down through and we'll try to isolate this variable being f. So the first thing we need to do is get rid of the divide by 5. So we will multiply by 5 because 5 over 5 is just 1. That means these will cancel out. But now whatever we do to one side, we have to do to the other side. So we have 5 times negative 0.1. That is going to be negative 0.05 equals negative 0.08 plus f. Now we will add 0.08 to both sides. The reason we added is because technically on the right side we had negative, so the opposite would be to add. Minus 0.08 and plus 0.08 are opposites, so that comes out to be 0. And then negative 0.05 plus 0.08, that would be positive 0.03. For our final question today, it says determine whether the statement is sometimes, always, or never true. Explain your reasoning. The product of 2 terminating decimals is a terminating decimal. So let's just do an example here and see what we think. Let's pick a terminating decimal, 2.5, and let's multiply that by a terminating decimal, 0.6. Both of those decimals terminate. 6 times 5 is 30. 6 times 2 is 12, and 3 more is 15. And we had 2 digits after a decimal point, so we're going to have 2 digits after a decimal point there. Pick another one. 0.15 times 0.2. The key comes in the fact that we already know there's going to be 3 digits after a decimal point. 2 times 5 is 10. 2 times 1 is 2, and 1 more is 3. And we have 3 digits after a decimal point. So it's 0.030. Okay, so two products, we're multiplying numbers together. They have terminating decimals. Well, then before we even start the problem, we're going to know how many decimal points there are. So therefore, we will always be able to know that it's going to be terminating. The quotient of two terminating decimals is a terminating decimal. So let's try this again. Just pick a few. 0.5 divided by 0.25. 0.5 goes in the house, 0.25 goes outside. Move your decimal point twice. So you have 25 divided by 50. 25 goes into 50 twice. So B said the quotient of two terminating decimals is a terminating decimal. 2.0, yeah, that terminates. So in this case, that is true. Let's try another one. 0.5 divided by 0.3. So 0.5 goes in the house, 0.3 goes outside. Move your decimal once, move your decimal once. And we have 3 divided by 5. 3 goes into 5 once. 3 goes into 20 6 times. 6 times 3 is 18. 3 goes into 20 6 times. 6 times 3 is 18. You can see a pattern here. That 6 is going to repeat. So what this is telling us is that sometimes you could have a terminating decimal, like we did here, and sometimes you could have a repeating decimal, like we did there. So we would say sometimes terminating.